Hi students, today I am going to explain what is conformation and conformation analysis. So conformation means there will be the arrangement of atoms around a molecule. So when there is a single bond between these molecules, the spatial arrangement of atoms which result in the rotation of groups about a single bond is called conformation of a molecule. For example, if you see here, so there is a rotation of groups around a single bond. It is called conformation, and a study of the energy changes which accompany these rotations. When these rotations are happening, there will be a change in the energy. So study of this is conformational analysis. So this conformation analysis is given by so many formulae or so many theories. So first is projection formula. So it is conventions for showing three-dimensional structure in two-dimensional on the paper. So projecting the structure in a two-dimensional way. So this conformation of two tetrahedral atoms linked together can be represented by two projections. Newman projection is one and Sawhorse projection is one. So what is Newman projection? It is a convenient representation of a molecule along one of its carbon axis. So along one of its carbon axis, the molecule is represented. Maybe it may be from a front view or from a rear carbon atom or back view. So bonds on the front and rear carbon atoms we can see here. So this is a front view, and from the back view this is rear view. So this one, or we can see from a Sawhorse projection. It is also like similar to Newman, but carbon-carbon bond here is not compressed. It is fully drawn. We can see all the carbon-carbon bonds. See here, we can fully drawn this structure and we can see. So this is a Sawhorse projection. So like this, and a Newman projection like this we can see. Then in Sawhorse projection, it is a view of molecule down a particular carbon-carbon bond, and groups connected to both front and back carbons are drawn using sticks at 120 degrees angles. So in Sawhorse projection, in Newman's projection we can see only at its axis at a front view or back view, but in this the groups connected in both front and back carbon are drawn by using sticks at 120 degrees. So we can see elaborate structure in this. Again, there are different conformations like staggered conformation and eclipsed conformation. So in staggered conformation, carbon single bond in which atoms or groups of one carbon are as far as possible. So in staggered means the carbon-carbon group will be as far as apart. So they will be very far. And in eclipsed conformation, same carbon-carbon single bond, but they are as close as possible. So we can see here staggered conformation, and the diagonal angle is 60 degrees. So the carbon-carbon bonding will be far. But in eclipsed conformation, we can see they are very near. Because of in eclipsed conformation, the carbon-carbon single bonds is very near, there will be electrostatic repulsion. So is created. Let's see how the stability will be there. It depends on four factors: steric strain, torsional strain, angle strain, and hydrogen bonding. So here steric strain means because of the carbon-carbon bonding. So between the atoms, there will be a repulsive interaction between them, and a force is created, force closer together than their atomic radii. This make the atoms to come more close than their atomic radii. Then torsional strain means the repulsion of bonding electrons when the bonds are forced from staggered to eclipsed conformation. So this is the electrons, the two bonding electrons will have repulsion, so that it will forced to change from staggered to eclipsed, means from very far to near. Then angle strain. So because it is forced, because of the repulsion between them, the angles will be changed. So any deviation from the normal bond angles, so are accompanied by this angle strain, maybe by steric strain or torsional strain. Because of this, angle strain will also occur, and also because of the bonding, hydrogen bonding between them. So all these factors will tell the stability of the conform. So we know that staggered form is more stable than eclipsed form. Why? Because the carbon atoms are as far as possible. That's why the repulsion will be less. But in eclipsed conformation, because they are very near carbon-carbon bonds, there will be more repulsive force. That's why it is not that much stable than staggered conformation. Then in staggered conformation, again there are different, because of the rotation of the angle. So what is conformation means? There will be the rotation in the spatial, so that so many conformations will be coming. When the when it is rotating about 60 degrees, then it is Guche form. When it is rotating 180 degrees, then it is anti form. We know that in eclipsed conformation, there will be very near, so angle will be, torsional angle will be 0 degrees. So we will explain it with one molecule. So we will see the conformation of ethane, propane and butane. In ethane molecule, torsional strain plays an important role, and torsional angle is also easily seen in Newman's projection. See here, torsional angle is 0 degrees centigrade, so 0 degrees, sorry, and it is having highest energy, and torsional strain is also more because more repulsive force. And again, when it is rotated by 60 degrees, then it is a Guche form, and it have least energy, and torsional strain is also minimum in this. And in anti-form, torsional angle is 180 degrees. So we can say staggered form is more stable than eclipsed. These two forms are more stable than eclipsed, and to convert from one form to another, so we have to use the energy up to 12 kg per mole. So the energy difference between these two conformations is 12 kg per mole. So this is about ethane. When it comes to butane, so we can see the eclipsed form. Ethane, see, all H are there. In the place of one H, one CH3 is added, so it will become propane. So 3 carbon molecules. So 1, 2, so backside 1. So 3. So it is propane in eclipsed form, in Guche form 60 degrees, in anti form 180 degrees, so 120 degrees. So the energy difference is 3.3 kilocalories is needed to change from one form to another, or 14 kilojoules per mole. More than ethane, propane wants more energy to convert. Then when we see butane, so again here in the, it is a least stable form, it is a syn periplanar form, or it is an eclipsed form, and again it is syn clinical, anticlinical form and anti-periplanar form. It is more stable form. 70% of butane will be in this form only. So thank you.